Hello everyone, my name is Johnson. My register number is URK18CS213. Today we will discuss the topic of dynamic routing OSPF. In the protocols in the interior part, there are two types, that is RIP protocols, that is routing information protocol we have discussed in the latest videos. And now today we will discuss about the interior part of OSPF, that is open shortest path first. In this we all know that what is the dynamic routing will do in the areas of these networks, the in the lands. In the dynamic routing is always chooses the shortest path, but in the OSPF it follows the Dijkstra's algorithm. Dijkstra's algorithm, the it will create areas to reduce the number of routes to propagate. OSPF can be divided into subdomains called as areas. That areas, why the areas is created to reduce the routing propagation. So in this OSPF, we will create a areas. We can see there are three areas. That is LAN one, that is with router one, and that is area two, that is with R2 router, and area three, that is with R3 routers. Here we have divided into the areas to propagate the routing information from and gathering the information from each other. Now we will go to the packet tracer and discuss how this will be done. In this we can see there are three PCs and three routers and three switches, and the routers are connected with the DC cable. Now you can see I have given the PC0 IP address, IPv4 address as, that is IP version 4, that is IP address as 172.16.1.2, and here we can see that there is /24. So I have given the subnet mask as 255.255.0, and this default gateway as 172.16.1.1. I have connected with this IP address of PC0. Now we'll open PC1. I have given the IP address as 172.16.2.2, and with this IP address is with /24. So I have given the subnet mask with that, and the default gateway is 172.16.2.1, and I have given this IP address for the PC1. Now for PC2, I have sent the IP address as 192.168.1.2, and we subnet mask with /24, and default gateway is 192.168.1.1. To gather the information from one area to another area, we have to connect the routers, and we have to connect the routers each other. We have to send the packets. When we see there is no connection between the PC0 and router, first we will connect with them. CLI. Here we have to type no. Now we have, if we want to go to user mode, the command is enable, and if we want to go to the privilege mode, the command is config t. Now we will connect the PC0 with this router 0. Command is int fa0/0, that is fast Ethernet, then the IP address, giving the default gateway address, that is 172.16.1.1. The IP address is and the subnet mask is 255.255.255.0, and again no message. Now we can see that this PC is connected with the router. The same will connect for the PC1 to router 2. Okay, open router 2, CLI. No. To go to user mode, the command is enable. To go to privilege mode, the command is config t. Here to send the information from PC1 to router 1. Here I have connected with fast Ethernet cable, that is int fa0/0. And the IP address assigned for that PC is 172.16.2.1, and the subnet mask is 255.255.255.0. Yes, no message. Now the PC1 is connected with router 2. Now we can see here PC0 to router 0 is connected successfully. We can see that green color is coming straight up. We can see here there is in here orange color. Sometime it will take to activate that. Now if you want to perform the action from PC2 to router 1, now we'll connect the PC2 with this router. Okay, no. Go to user mode, commands enable. To go to privilege mode, that is config key. Here we will assign the PC IP address. It is connected with fast Ethernet cable. This int 0 by 0. Now we can see before that there is no connection, so it is showing that red color is state down. When we connect this, the state will be going up. Now we can see here the connection established between PC1 to router 2 and router 0 to PC0. Now we will give the IP address 192.168.1.1. Subnet mask is 255.55.55.0. No message. Now we will send the packets if there is a information going from PC to router or not. Now you can see the information is successfully going from PC0 to router 0. I will check for PC1 to router 2 as well as. You can see PC1 to router 2 is successful. Now we will check for router 1 to PC2 successful or not. PC2 to router 1 is successful. Now when we send a packet from PC0 to PC1, it is failed because there is no connection between router 0 and router 2 as well as from router 0 to router 1. Now we'll establish connection between them. Connect that int. This is connected as DC cable. So here we can see that the difference between DC cable and here DD cable. Now DC cable, the starting it will be as clock symbol. That is the difference between that. Now it is connected serial 2 by 0. Now here I am assigning IP address as 172.16.3.1. The default that is subnet mask is with /30, so the subnet mask is 255.55.55.252. Here my SH. Now here I am assigning the clock rate as 64,000. I will connect the same the router 2 int SC 2 by 0. IP address as 172.16.3.2 and with /30 the subnet mask is 255.55.250. Now SH. Now we can see the information from router 0 to router 2 is successful. The state is up. Now the same configuration will do for router 1 to router 2. Int SC 3 by 0. IP address as 192.168.10.10.9, 255.255.255.252. And we see that I have given the IP address 192.168.10.9, and the subnet mask is 255.255.252. No message. Here clock rate 64,000. Now you can see that change step down. We will connect router 1. This in SC 3/0, IP address as 192.168.10.10. The subnet mask is 255.255.255.250. Then no message. Now you can see the state is up. Now you will connect the same with router 0 to router 1. Int SC 3/0, IP address is 192.168.10.5. The subnet mask is 255.255.255.252. SH. Clock rate is 64,000. You see that change state to down. Now to state up, we have to connect the router 1. That is int SC 2/0. And then IP address is 192.168.10.6, 255.255.252. No SH. Now it is changed to up. Now we can send the information from router 0 to router 1 as well as from router 0 to router 2. To access that, we have to for the router 0, the router 2 and router 1 IP address should be there in that to access the information and send the information from that. Now to send the information from each other router, we have to connect with it dynamically, that is with router with OSPF, that is open shortest path first. The command is router OSPF 10. This command is globally configuration mode to router 1, router OSPF 10. And here I am giving the network. I am adding the networks as network 172.16.1.0, and here we can see that it has the network of /24. Now here for the OSPF we have to give the complement of that. For the /24 the complement is 0.0.0.255. Now the area 0. This area 0. Now here in this I have before told that to the areas is created to reduce the routing to propagate. When we see here the configure network statements of the networks on R1 use an area ID of 0. We are connecting by the areas of the network. So here I have given that area 0 for that. Then network, and I'm adding the PC1, that is 172.16.2.0, and we can see that it has /24. The complement of that is 0.0.0.255, and the area 0. And I'm adding the third PC, that is network 192.168.1.0 0.0.0.255 is also /24, in area 0. Now I will connect with the routers network, that is for the router 0, the network is 172.16.3.0, and we see that it has with the /30, so the complement of that is 0.0.0.3, the area 0. Now I'm adding the router 1 to router 2 IP address, that is network 192.8.10.8, and for that complement is 0.0.0.3, the area 0. Now here the another IP address is that router 0 to router 1, that is 192.168 dot 10.4, complement of that is 0.0.3, and the area 0. Now here I have connected the 3 PCs and the 3 routers IP address. Now the same we will do for router 2. Enable config, that is the command is router OSPF 10, that is global configuration OSPF 10. Then I am adding the network addresses, this 172.16.2.0, and the complement for that is 0.0.0.255, in the area 0. So it is 16.2.0 area. Now I am adding the first PC address, that is 116.1.0, area 0, and the third PC IP address is 192.168 dot dot 0 dot 0 complement for that is 0.0.255, area 0. Now we will add the routing's IP address dot 3.0, and the complement for that is 0.0.3, for that is area 0. Second, we will add that is 192.168.10.8, 10.8. The component for that is 0.0.3. The third routing IP address is 168.10.4. Now the same we will do for router 1. Command is router OSPF 10, adding the network's IP address. It is 192.168.1.0, and complement for that is 0.0.0.255, and the area 0.0.255. Now I am adding the PC1 IP address, that is 172.16.2.0, and I am adding the PC0 address, it is 172.16.1.0. Now I will add the routing's IP address, 16.3.0, and the component for that is 0.0.0.3, and I will add the second routing IP address, that is 192.68.10.8, and the component of for that is 0.0.0.3, area 0. The third IP address is 192.168.10.4, 0. Area 3. Now we have connected the networks of that. Now we will check the packets from each areas, that is from PC0 to PC1, that is successful. Now we will send the from PC0 to PC2 is successful. Now when we are going from PC0 to PC2, there are two parts to go for packet, that is from router 0 to router 2 and router 2 to router 1, and then PC. Then there is a straightway connection, that is from router 0 to router 1. From which way the packet will go, now we will check the simulation mode. You can see that the packet is going straight away path, choosing the best path. Now in the full form of OSPF, we can see that the open shortest path, that is it will choose as the open shortest path, which is open and the connection is open, then it will go that path. Now the difference between this is, when we cut the path from router 0 to router 1, it chooses the other path from router 0 to router 2 and router 2 to router 1. This is the open shortest path. Now if the paths are open of shortest path, then the router will go to that path. When we cancel that path of shortest path, then it will choose the another path to pass away from the from one PC to another PC. Now we'll check for PC1 to PC2. PC1 to PC2 is successful. I will check for PC1 to PC0, and from PC2 to PC1 is successful. Now for PC2 to PC0 is successful. Now we can gather the information from any LAN, that is from area. Any area we can access the information and send the information. Here there are some commands to display on that. Now here show IP OSP neighbor command to verify that each router lists the other routers in the networks as neighbor. Now we can see that when we type that command, that is show IP OSPF neighbor. Neighbor, we can see for the router 0 the neighbors are 192.168.10.10 and the 10.9. And now we will see that for the router 1 what is the neighbors of router 2. SHIP OSPF neighbor. Now we can see for the router 1 the neighbors are 192.168.10.5 and the 10.10. Now we will check in router 1 which are the neighbors for router 1. SHIP OSPF neighbor. Now for this the neighbors are 192.168.10.9 and the 10.5 are the neighbors for router 1. Now now we will check for show IP SHIP route. Now it will show all the networks which are connected to that router. Now here we can see here there are two OSPFs are connected to this router 0, that is 192.168.1.0 and 192.168.10.0. These are directly and the 10.4 is directly connected with this router, and the 1.0 is directly connected with this router. And for the router 2 we will see SHIP route. Now we can see there are three OSPF connections that are 192.16.1.0 and 192.168.1.0 and 192.168.10.4 is OSPFs, that is open short path first connections are directly connected with this via and the 172.16.3.1 with this connection the 192.168.10.4 is via connected with this 110. We know that 110 is the administrator of for this OSPF. Now we will see for router 1 SHIP route. Now here we can see that there are three OSPF connections, that is 172.16.1.0 and 170.16.2.0 and 170.16.3.0 is connected. Now you can see there are two directly connected and networks are connected with this. And to verify OSPF protocol, there are some troubleshooting commands that we will perform in this. There are show IP OSPF, and the next one is show IP OSPF interface. will see here. Next command is interface brief. And we will see OSPF database. Now here we have three databases for this router 0, that is 192.168.10.9 and 10.5 and 10.10. The next one is debug IP OSPF events. Now we can see that OSPF events is on. Now we can see there are several connections are coming, and we can know that update. We can see that updates of this router 0 networks. To cancel this, no debug. In this we have seen the information passing from one LAN to the another remote LAN. Now when we send the packet from PC0 to PC1, for PC0, PC1 is the remote LAN, and the PC0 as well as PC2 is remote LAN. Now we can access the information from that by the from the dynamic routing of OSPF with areas. Now we can send the packet from any PC, from PC2 to another remote PC. We can see that information is successful, and gathering the information from that. Now when we see when we see the OSPF dynamic routing protocols, the commands are, first the command is router OSPF 10. This command is in global configuration mode to enable OSPF in the routers. When we type the router OSPF 10, it will be a global configuration for router 0. When we type the that command in router 2, that will be OSPF a global configuration for that router 2. When we open router 1 and type the command of router OSPF 10, this will be the global configuration of them. Now this is the commands, and after that we will add the networks for that router to access the information from another remote PCs. Now this is all about the dynamic routing OSPF, and we also have seen some troubleshooting commands of OSPF, that is show IP OSPF interface, show IP OSPF, show IP route. This will show all the connections which are connected with that routers. You can see that show running config. When we type sh running config, we can see that this is a show running config. We can see that interface fast Ethernet connection is connected with this internet with this IP address, and these are the troubleshooting commands of some. When we type debug IP OSPF, debug IP OSPF, we type in debug IP OSPF. See that in OSP adjacency events OSP events, debugging IP OSPF. This is the command of that. Now these are the show interfaces, troubleshooting commands of some time creating OSPF. Okay, okay, thank you. We will see in the next video. Okay, thank you.